Welcome back to Kamal Kunj Home Academy, Encounter with Mathematics. In this session, we will solve some problems based on straight lines. So let us start first with the last question. It is given that theta is the angle between the lines joining these 2 points and these 2 points. Then we have to prove that tan theta equal to 11.23. So slope of line AB line joining points A and B M1 is equal to 3 minus 0 upon 2 minus 2, 3 upon 2. And slope of line joining points C and D. Suppose M2 equal to y2 minus y1 upon x2 minus x1 is equal to 5 minus 2 means plus 2 upon 3 minus 2 is equal to 7. So angle. So here M1 is equal to 3 upon 2 and M2 is equal to 7. Now we know that angle between two lines with slopes M1 and M2 is given by tan theta is equal to m2 minus m1 upon 1 plus m1 into m2. Now here m1 is equal to 3 upon 2, m2 is equal to 7. This implies that tan theta is equal to 7 minus 3 upon 2 upon 1 plus 3 upon 2 into 7. This is equal to 14 minus 3 upon 2 divided by 2 plus 21 upon 2. This is equal to 11 upon 2 divided by 23 upon 2 is equal to 11 upon 23. Hence, this implies that tan theta equal to 11 upon 23. Hence the result. Now let us solve the next question. Here slopes are given and you have to find the angle between the lines. First is let m1 equal to √3 and m2 is equal to 1 upon √3. Now we know that tan theta is equal to m2 minus m1 upon 1 plus m1 into m2. This is equal to m2 is 1 upon root 3 minus root 3 upon 1 plus root 3 into 1 upon root 3. Is equal to 1 minus 3 upon root 3 divided by 2. This implies that tan theta is equal to 2 upon root 3 divided by 2. This is equal to 1 upon under root 3. This implies that theta is equal to 30 degree. Value of tan 30 degree is 1 upon root 3. Hence theta is equal to 30 degree. Second portion is m1 is equal to 2 minus under root 3 and m2 is equal to 2 plus under root 3. Then we have to find the angle between these two lines. So slopes are 2 minus root 3 and 2 plus root 3. You know that angle between the two lines is given by tan theta equal to m2 minus m1 upon 1 plus m1 into m2. Here m2 is 2 plus under root 3 minus 2 minus under root 3 upon 1 plus 2 minus root 3 into 2 plus under root 3. Like that, tan theta is equal to 2 plus under root 3 minus 2 plus under root 3 upon 1 plus 2 square minus root 3 square. This is equal to 2 root 3 upon 1 plus 4 minus 3. So equal to 2 root 3 upon 2 equal to root 3. This implies that tan theta is equal to root 3. This implies that theta equal to 60 degree. Because value of tan theta is root 3 if theta is 60 degree. So value of theta will be 60 degree. Now let us solve the last question. So that the points A, B and C are the three corners of a square ABCD. There is a square ABCD. A, B, C and D. There is square ABCD. The coordinates of A are 0 and 6. Coordinates of B are 2 and 1. And coordinates of C are 7, 3. Now join the diagonals. Let O be the point of intersection of the diagonals. Now we have to prove that point A, B, C are three corners of square ABCD. Now let us find the length for line segment AB and BC and AC using distance formula. AB is equal to x2 minus x1 whole square plus y2 minus y1 whole square. This is equal to 2 minus 0 whole square plus 1 minus 6 whole square is equal to 4 plus 5 square means 25 is equal to under root 29. Similarly, find the length of line segment BC. Using same formula, distance formula. 7 minus 2 whole square plus 3 minus 1 whole square is equal to 5 square plus 2 square equal to 25 plus 4 equal to under root 29. Just find the length of diagonal AC. Seven minus 0 whole square plus 3 minus 6 whole square. This is equal to 7 square means 49 plus minus 3 square means 9. This is equal to root 58. Thus we have the lengths of 3 line segments AB is under root 29, BC under root 29, and AC is equal to under root 58. Here we see that AC is equal to under root 58. This implies that AC square is equal to 58. This is equal to 29 plus 29. This is equal to 29 is AB square plus BC square. This implies that AC square is equal to AB square plus BC square. This implies that ABC is a right triangle with sides AB and BC equal. So this implies that triangle ABC is a right triangle with angle B is equal to 90 degrees. Also, if you find the slopes of AB and BC, also slope of AB is equal to one minus 6 upon 2 minus 0 means minus 5 upon 2, and slope of BC is equal to 3 minus 1 upon 7 minus 2 means 2 upon 5. Now if you multiply these two, slope of AB multiplied by slope of BC is equal to minus 5 upon 2 into 2 upon 5. This is equal to minus 1. This implies that BC is perpendicular to AB. So since AB is equal to BC and BC is perpendicular to AB and angle ABC is 90 degree, that is BC is perpendicular to AB. Hence ABC are corners of a square. Hence A, B and C are the corners of a square. Now next is to find the slope of diagonal BD. Now let's find the midpoint of AC. Point of diagonal AC is O. Therefore, coordinates of O point O are x1 plus x2 upon 2 and y1 plus y2 upon 2. This is equal to here x1 is 0 plus 7 upon 2 and 6 plus 3 upon 2 is equal to 7 upon 2 and 9 upon 2. So coordinates of midpoint of AC are 7 upon 2 and 9 upon 2. Coordinates of midpoint O of AC 7/2 and 9/2. Slope of AC 3 minus 6/7 minus 0 equal to 3/-3/7. Now we know that diagonal of a square, diagonals of a square bisect each other at right angle. Hence, slope of AC multiplied by slope of BD is equal to -1. This implies that slope of BD equal to -1/slope of AC equal to -1/-3/7. This implies that slope of BD is equal to 7/3. So slope of BD is 7/3. Now second question is coordinates of the fourth vertex. We find the coordinates of point D. Now we have already defined the coordinates of midpoint of AC. And since diagonals bisect each other, therefore coordinates of midpoint of BD will be also same. Since diagonals of a square bisect each other, therefore coordinates of midpoint of BD is equal to coordinates of midpoint of AC. let xy be the coordinates of point D, x and y. Let x and y be the coordinates of point D. Hence, coordinates of midpoint of BD x1 plus x2 upon 2 and y1 plus y2 upon 2. Here x1 is equal to x and x2 is equal to 2 and y1 is equal to y and y2 is equal to 1. Therefore, this will be equal to x plus 2 upon 2 and y plus 1 upon 2. Hence, x plus 2 upon 2 will be equal to 7 upon 2 and y plus 1 upon 2 will be equal to 9 upon 2. This implies that x plus 2 equal to 7 and y plus 1 equal to 9. This implies that x equal to 7 minus 2 and y equal to 9 minus 1. This implies that x equal to 5 and y equal to 8. Hence, this coordinates of fourth vertex D are 5 and 8. Now we will stop here and continue further in the next session. Till then, goodbye and thanks for watching.